So we'll, unless there's some questions on problems that we've done, we'll look at problem 34. And it says, given the heating and cooling requirements for a greenhouse, it is important to calculate surface area, determine the surface area of the greenhouse with the dimension shown, round to the nearest whole numbers. I'm going to make the assumption that the floor of the greenhouse is not going to be part of the surface area. That the surface area is just the outside of the. So what we have is a prism, and the ends of the greenhouse are going to be the ends of the prism. So the surface area is going to be the surface area of, I guess, the gable end plus the surface area of the sides of the prism less the base. So what we're given here is they have there, and here it's 12 feet. And then they have, this is 6 foot 4 inches, and this is 23 feet. And then this is 96. So what we're going to have to do is we're going to have to figure the ends of that. So with the information given, we can determine this height right here by taking the 12 feet, the H is going to be 12 feet minus the 6 foot 4 inches. So that's going to be 5 foot 8 inches. Now we have enough information to calculate that end. So what we're going to have to do we're going to do 2 times, and then the part is, there's 23 by 6 foot times 6 foot 4, and 6 foot 4 is about 6 1/3.
Mm-hmm. So you wouldn't convert to inches.
I would convert to feet. Mm-hmm. Then you have to add to that part that has the H in it, and that's going to be 1/2 of the base, which is 23, times that H, and that H is 5/8, so that's 5 2/3, right? 5.67. This is 6.33. So that will give us the two ends. And then we have to add to that. In order to do this, we're going to have to calculate this, because we have to have that part of the perimeter less that 23 on the base. And in order to do that, we're going to realize that the distance from here to here is going to be half of the 23. So it's 11.5. And then this one, we calculated this to be 5.67. So then we can figure out this, I guess we could call it C, because it's going to be the hypotenuse of the right triangle. So C is going to be equal to square root of 11.5 quantity squared plus 5.67 squared, right? And maybe we should go ahead and calculate that so that we can get a number. This is going to involve a lot of round off here, so it's not as good as I would like to have it be. So it's a second square root 11.5 squared plus, that was 5.67, right? That's 12.8. Maybe we do 12.82. So now, if we're going to neglect the bottom of the building, and I think that's what we have to do, then the area around the perimeter is going to be, we have to do the perimeter times the height. So the perimeter is going to be 2 times that 12.82 plus, and then there's two sides, 6.33, and that's times the height, 96. Now that's saying that it's not including the floor of the building. That should be the surface area. Wow. I'll put that in the calculator. Okay, I'm going to have to go back and forth. There's no way I can remember it. So it's 2 times, I'm already, is it 12.3? What is it? 12.8. I have to do this. 2 times 23 times 6.33. Times 23 times, what was that? 6 point what?
3.3.
3.3? Plus, right? And I can go 0.5 times 23 times 5.67. If I could remember that. 0.5 times, help me out. I don't have a good long-term memory. 23 times 5.67. 23.
Because you got a 0.5 there.
5 point.
That's correct.
Okay.
That's supposed to be correct.
Half.
Yeah, never mind. Thank you.
5.67. And then put a bracket. Yeah, you see what she said, see, was I put 1/2 in place of that. 0.5. And I got the bracket closed, and I gotta go plus and then put another bracket. Holy, oh, that's 12.82, okay. Plus 2 times 12.82, right? Dang it, I didn't put that darn bracket in. What the dickens did I do?
You need to leave out
What?
bracket. You need to leave out the bracket in front of the six.
Yeah. I wonder how come, I thought it was in the right spot. I gotta put it right over here.
Yes.
Second, insert. Bracket. Okay. And it's plus,
Plus
and it was 2 times that other, right? 2 times the,
6.23.
and that got me, and I closed the bracket, that got me the part of the circumference I wanted. Then I multiply it times 96.
Yep.
4,098. If I did it all right. What did I have, 98? And that's all they wanted, is just to calculate that surface area, right? Nearest whole number, and that was that the whole number? Yeah. And that would be feet squared, right? Now, if I were to give you a problem like this, I would specify that that floor is in or out, because I'm not real clear on whether the floor is in or out, but it seems like the floor is probably out. .36. Saying the inside of a cylinder tank, cylindrical tank used to hold resin must be coated with corrosion preventative. The tank measures 7 foot in diameter and 5 foot high. 1 gallon of corrosion preventative will cover 10 feet squared. So I think that could be actually round. Pretty close to round. a real big tank. Okay, anyway, it says 7 feet in diameter, so from here to here, it's 7 feet. And then it's 5 feet high, so from here to there, it's 5 feet. And being it says it's a tank, I'm assuming it has top and bottom, it needs to be covered. So the surface area is going to be the surface area of the ends plus surface area side. Surface area of the end is pi times the radius squared. So it's pi, and the radius is 3.5, right? And then the surface area of the side is the circumference. And the circumference is pi times the diameter, so it's pi times 7 times the height, 5. And then what we have to do with this surface area once we calculate it is we have to divide it by 10.10 feet. That's going to be square feet in order to get the gallons. That should get us the gallons. So I don't have to put so much in. I could take the pi out. That's not 7 times 5.
You need 35.
7 times 5, yeah. Now I got it right. Pi. Okay. So it's pi times bracket 3.5 squared plus 35 close that bracket and then divided by 10. Now, because all of these things are multiplied, I can divide it by 10 without putting a bracket around that whole big thing, like that, and it'll be correct. It's 14.8 gallons. Does it tell us how many gallons will be needed to coat the tank? So 14.8 gallons. Assume that the sides, top, bottom of the tank will be treated. So that just when I said the assumption that I assumed there was a top on it, that just verifies that. Okay, 38. Says a golf ball has a diameter of 1.68 inches. A box in the shape of a square prism to hold 3 golf balls will be made out of cardboard. What is the least amount of cardboard that will be needed, assuming that the centers of the ball will be collinear when in the box nor the flaps to be folded in on the ends of the round. And round your answer to the nearest tenths. Average. So 38. So it's telling us it's going to be a square prism. And I'm not going to be able to, this golf ball that sets in there, and then the next one back, I don't know how to draw it. So that. Let's see. The center here, this center goes through all those centers. Oh, I keep doing it the wrong way. I can't get it.
So I think you're fighting a losing battle.
I know it. What it is this next one back. It's going to be like this, and then this next one back. It's going to be like this. And those centers go through, and it touches the back. So each one of those balls is 1.68. So as you go back, the first ball is 1.68, and then the next ball is 1.68, and then the next ball to get to here is 1.68.
A grand total of 5.04.
And it touches, and then this distance from here to here is 1.68. So we want surface area. So this is 1.68. So the surface area is going to be the area 2 times the area of the end plus the circumference times, and what did you say this total was?
Total is 5.04.
I guess I could put 3 times 1.68. So the ends, it's 1.68 squared, and the circumference is 4 times 1.68 times 3 times 1.68. 1.68 squared. So this is 12 times 1.68. Okay. 25.8. Eight, what is that? Inches, inches squared.
So I'm not sure where you're coming by 4 and the 3. The 4, I can understand 1, 2, 3, 4, 4 lengths of the box.
And then the 3 is the length of the bottom. 3 times 1.68. You called it 5 point something. I don't know what it was, but
Oh, I gotcha. Yeah.
I just called it 3 times 1.68. Okay. All right. So 40. It says a gutter is to be formed. Did that answer all your questions, Vince?
Just give me the final solution. I want to see if it comes out 25.8.
25.8. Okay. 40 says a gutter is to be formed from a length of 10 bent. So if the cross section is a semicircle, 4 inches in diameter, if a total length of 210 feet is needed, and an extra 3/4 of an inch on each ends is required. Calculate the number of square feet needed. Okay. So now, what has to happen, let's see, is it going straight up from here? Straight up from there. I should have made it bigger. Let's see. From here to here, it's 4 inches, right? So before we go too far, we better convert it to feet. So that's what, 1/3 of a foot? I wonder if 1/3 is going to work. And then this is going to be 3/4 of an inch. Oh boy. That's going to have to be divided by 12, right? So it'd be 3/48 of a foot. This is an inch. This is a foot. That's a foot. And then the distance from here back to here is what?
Again.
Feet, right? So it'd be better to figure the half of a circle sphere. Sphere. So it'd be 2 times half the circle. That's 4 inches, and then it'd have to be half the circumference times that length. That would be the that surface area is 1/2 of the circular sphere. And if the radius is that, the diameter is going to be 1/2 of 1/3, right? So the area of the end is going to be pi do I do 1/6 squared. And it's going to be 2 times that, right? Half of 2 times that. It's 1/2, and there's 2 of those ends that are pi times 1/6 squared. That's going to take care of those 2 ends, less the little lip up there. And then we're going to have to do the circumference, so it'll be half of that circumference, which is pi times the diameter, which is 1/3, times the height, which is 210. Now that's going to be that half of a cylinder. Then we have to take 2 times the rectangular going along the side, so that's 3/48 times 210 plus 2 times the height is 3/48 times 1/3, right? These two cancel out, so this is pi times 1/6 squared plus, we can do some reducing there, right? This goes into there 70, the 2 goes into there 35. Pi plus 2 will go into here 24. 24 and 21. Any way to reduce that? We can go 3 into 24, can't we? 24 is, isn't it? 868, right? Does 8 go into 21? We can take a 2 out. Can't take a 4. 105. At least we got it down to there. 3 goes there, and this goes into 24. So what I got is I got this thing, this 105 over 4. And the next one is a plus 1 over 24. Is that right? So it's pi times 1/6. I better bracket it. 1 divided by 6 and squared, right? Plus, what was that next one? 35 pi. 35 pi plus 105 over 4. 105 divided by 4. Was the last one 1 over 24? What was the last one? 1 over 24. 1 divided by 24. Now that's what we meant to do, right? We meant to do 1/6 squared. See, if I had to put pi times 1 divided by 6 squared, it is squared 6. That probably would have worked. But it's better to do it that way. Okay. 136.3. And this is all in feet, right? Nearest square foot. So it's 136 to do what they want to do. Okay. .42 says a water tower is shaped in the shape of a right circular cylinder, has a stairway to the top that winds around the outside of the tower. The tower is 50 feet in diameter, 40 feet tall, and the stairs wrap around the cylinder exactly twice. How long to the nearest foot is the stairway? Okay.
Professor, what was the last answer, please?
136.
Yep, thank you.
Okay. So now we're going to have to freehand this thing. There. Should have done that one.
You just want the circumference twice?
No. That won't work. If you take that thing and you unroll it, if you start right here, and you cut it right there, and you unroll it, Oh, it's, I should do this. This is 40. And this is 50. And if you unroll that thing, and this dashed line is where that starts. Unroll it. And what you have is your, at the very top, when it's up here, it's going to be right here. Let's see if I can do this. Go halfway down. The stairway is going to be this, and like that. Right?
Mm-hmm.
So where your stairway is going to be. And let's see. This is this length right here is 40. And that length right there is, no, 50 is a diameter. That's a circumference. Equals pi times the diameter, which is pi times 50. All right? When you unroll it, it's going to be the circumference laid out. 50. Now if I got my numbers right. So then it wants to know the length of the stairway. So what it's going to be is it's going to be two, this thing and this thing are equal. So you have to find out what that is and double it. Well, if that's 40, this is 20. Right? Now you should be seeing what we're going to do. We're going to take the length, yeah. So the total length is going to be 2 times, and it's going to be the square root of, and it's going to be 20 squared plus pi times 50, that quantity squared. Isn't that right?
You wouldn't just take the 50 for the base of the triangle?
No, because it's a circumference.
Okay.
Second. Pi. What am I doing? 2, second. I'm good. Back up. It's got to be 2 times second square root, right? 20 squared plus bracket second pi times 50 quantity squared. Go out from underneath it, put a bracket. 316. What did it want us to do with that?
How long would that staircase be?
Does it say nearest foot? 317. And that was all in feet, wasn't it?
Yes.
Okay. Okay. So do you have any questions on that thing? Okay, we'll start section 3.5 next time we meet. So.